Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter Relations and Functions, which is your first chapter from your 12th standard CBSE Mathematics. So I will continue with exercise 1.3, first problem in page number 18 of your textbook. So page number 18, exercise 1.3, problem number 1. So what is given? Given is f is a function from the set 1, 3, 4 to 1, 2, 5. And g is a function from the set 1, 2, 5 to 1, 3, and f is defined as this and g is defined as this. We have to find g of f. We have to find the function g of f. So solution is, now g of f, first we need to define g of f is from which set to which set. We have to define the domain set and codomain set for g of f. G of f, f starts from which set? F starts from 1, 3, 4. So it will be from 1, 3, 4 to g is ending with the codomain is 1, 3. 1, 3. So your g of f will be a function from this set to this set. This is a domain, this is a codomain for g of f. Now let's find what is g of f of 1. So for each element you have to find. So what is g of f of 1? G of f of 1 is g of f of 1. That is equal to g of, what is f of 1? So when they say 1, 2, it means f of 1 is 2. Right? 1 goes to 2. So meaning of this is f of 1 goes to 2. So your f of 1 is 2. And g of 2, so 2 goes to 3, so it is 3. 2, 3 means g of 2 is 3. F of 1 is 2. That is the meaning of 1, 2 means f of 1 is 2, f of 3 is 5, f of 4 is 1. Similarly, g of 1 is 3, g of 2 is 3, g of 5 is 1. Fine, so that's how the definition of the function is. Now, let's find what is g of f of, then that's the next element in this set, which is 3. That is equal to g of f of 3. What is g of f of 3? G of, what is f of 3? 3 goes to 5. So 5. And for g of 5, 5 goes to 1. So 1. So similarly, g of f of the last element 4. Right? So that is equal to g of f of 4. That is equal to g of, what is f of 4? 4 goes to 1. F of 4 is 1. So which is g of 1? And g of 1 is 1 goes to 3. So it is 3. Fine. So if you write our G set, so we will write it as G of f set is G of f function is equal to, we can write 1 goes to 3, so 1, 3, 3 goes to 1, which means 3, 1, 4 goes to 3, 4, 3. So this is your G of f function. Either we can write it like this or we can write it like this. We can stop like this also. But since the function f is given as an ordered pair and g is also given as an ordered pair, so I am writing the g of f also as an ordered pair. So this completes the first question from exercise 1.3. So all of you can pause the video and take the notes. I will go to the second question. So second question is, so find, let f, g and h are functions from R to R. So what is given? So given is f is a function from R to R, g is a function from R to R, f, g and h is a function from R to R. And we have to show that. So what we have to prove? We have to prove two things. The first part that we have to prove is, we have to prove that f plus g of h equal to f of h plus f of g, so g of h, f of h plus g of h, we have to prove. And second, that the step that we should prove, second part is f dot g of h equal to f dot h, sorry, f of h dot g of h. Dot means multiplication. Here dot means f into g. This is composition of, if you put of, then this composition of function. This f dot g means multiplication of two functions. Now we need to prove this. Now what is the proof? The proof is, let's start with this. So what is f plus g of, so f plus g of h is defined as f plus g of, so suppose if I take Where is the rest? Okay. So if we try to find f plus g of h of, so that can be written as, if we apply it on an element x, so that will be equal to f plus g of h of x. So we are taking the element and we are applying this x. So this is true for every x coming from the set R. H of x. So it's from this R. So that is equal to, we can write this as f plus g of h of x is what? This is f plus g of x of f of h of x plus g of h of x. Right? So f plus g means f of h of x plus g of h of x. That is the definition of sum of two functions. F plus g of x is f of x plus g of x. Right? So you can, f is applied on h of x element plus g is applied on h of x. That is the definition of f plus g function. So now what is f of h of x? That is f of h of x plus g of h of x means g of h of x. So if I remove the bracket, I have to put O. If I remove the bracket, I have to put O. You can remember like that. So this becomes f of h plus g of h function of x, the element. So what we got? We get f plus g of h of x equal to this. Right? So which means your xx can be taken out. So you will get f plus g of h equal to f of h plus g of h. So we have proved this. Fine. Now we'll go to the second one. This is for the first one. This is proof for the first one. First section. This is the proof. The second one. So second one is what? Second is f into g of h of x. We will find. We will operate on this, or the function is applied on that element x, where x is coming from the set R, right? So this is true for every x. This is true for every x belonging to R. That's when we can say both are equal functions. So now, so this is x. So that is equal to f dot g of h of x. Right? If you remove the O, you have to put the bracket. That is equal to f into h of x. Sorry, f of h of x into g of x. G of h of x. Right? So when you have multiplication of two functions on an element, that is same as applying f on that element into g on that element. That is f dot g on that element. So f multiplied by g function on the element is f on the element into g on that element h of x. So that is equal to, now what is f h of x? F h of x is f of h of x into g of h is g of h of x. Now again we can take f of h dot g of h of x. That is your f dot g of h of x. So you can take the x out and we can put the multiplication of the function and operating on x. You can also put x bracket x. Because our definition is what? General definition of two function is f plus g of x means it is f of x plus g of x. Similarly, f into g of x, which we studied in our 11th standard, is f of x into g of x. Right? So this is like that. F into g of x is f of x into g of x. That is, this is f of h of x. That is f of h of x. G of h of x is g of h of x. Now again, this is multiplication of two functions. So I can write f of h dot into g of h of x. That is same as f of h of x into g of h of x. So now xx can be taken. So this is true for every x belonging to R, set of all real numbers. So this is true for every x belonging to R. Since it is true for every x, so which means the two functions are same. So f into g of h is equal to f of h into g of h. F of h into g of h, which is this. Second part is true. So this is true for any two functions or any three functions. Right? All of you can pause the video and take the notes. I will go to the third problem. The third question is, let's see what is given. So given in the textbook is f of x. Your f of x is equal to, right? So your f of x, oops, okay, here. So your f of x is equal to, so we have to find, so f of x given as f of x is equal to mod x, and your g of x is defined as mod of phi x minus 2. Now what we need to find? We have to find, and it is from R to, anyway, nothing is given, so it should be from R to R. So f is defined as f of x equal to mod x, g of x is phi x minus 2. Now we have to find first part. This is the third first part. Right? Third problem, first question. Third problem, first question. First part, to find f of g and g of f. We have to find what is f of g and what is g of f. Right? So I'll write the g of f. Doesn't matter whichever we write. So g of f, comma f of g. We have to find these two. Right? So now what is f of g solution? What is g of f? G of f of x is nothing but g of f of x. That is equal to g of, what is f of x? F of x is mod x. So modulus of x. That is equal to g of mod x. Now what is g of mod x? Which means if x is there, I have to put x here. If mod x is there, I have to put mod x here. So this becomes mod of phi into mod x minus 2 mod. This is like g of x. X is mod x. You have to think your mod x as x. So your g of x is phi x minus 2. So g of mod x is mod of phi mod x minus 2. So this is your g of f function. So what is your g of f function? Your g of f of x function is equal to this one, which is mod of phi mod x minus 2 mod. Fine. So this is how we find the function g of f. Next one is, we will try to find f of g. Now what is f of g? F of g of x equal to f of g of x. F of g of x, that is equal to f of, what is g of x? G of x is mod of phi x minus 2. Your g of x is mod of phi x minus 2. So that is equal to, now what is f of mod of phi x minus 2? F of x is mod x. So f of mod of phi x minus 2 will become mod of x, I should put. So whatever is here. So our x itself is mod of phi x minus 2. So I should put mod of phi x minus 2, mod. This is like f of x equal to mod x. So this entire value, including the mod, this entire value is called as x, including the mod. So we should put mod x, which means mod of phi x minus 2, which is same as phi x minus 2, mod of phi x minus 2. Because mod is mod. The mod is already absolute value. So mod of minus 2 is same as mod of minus 2. Right? So it becomes mod of phi x minus 2. So that is your f. So your f of g of x is equal to mod of phi x minus 2. Fine. So we have found g of f and f of g. Right, now the second part, the third question, second part is f of x is given as 8x cube. So it is 8x cube, and the g of x function is given as x power 1 by 3. Now we should find what is g of f and f of g, the same thing. Right? So to find this g of f comma f of g. Now solution. What is g of f? G of f means g of f of x, that is equal to g of f of x. Then if you want to find this function, you have to operate that function on an element. Only then we can Now use the definition of f of x and g of x and find that. So what is that? Is g of what is f of x? F of x is 8x cube. So I put f 8x cube. So g of 8x cube because f of x is 8x cube. Now that is equal to now g of x is x power 1 by 3. But x is what? X is your 8x cube. So in the place of x you have to put 8x cube. So we'll put 8x cube whole power 1 by 3. This is like g of x is x power 1 by 3. When I will say x, but I will write 8x cube because this entire thing should be treated as x. So this is like g of x. G of x is what? X power 1 by 3. So what that will become? So that will become 2x. Because 8 power 1 by 3 is 2. X cube power 1 by 3 is x. So g of f of x is 2x. So I can write here g of f of x value is finally 2x, which is this. Now let's find f of g of x. That is equal to f of g of x. That is equal to f of g of x. Now what is g of x? G of x is x power 1 by 3. So f of x power 1 by 3. X power 1 by 3. So what is f of x power 1 by 3? That is equal to, now f of x is 8x cube. So in the place of x we have to put x power 1 by 3. So this, to treat this as x, this is f of x. F of x is 8x cube. So f of x, but x is what here? X power 1 by 3. So I will put 8 into x cube. X power cube. Right? So that will become what? This looks like now 8x cube. So 8x cube and x is x power 1 by 3. So f of x is 8x cube. So here this entire thing x power 1 by 3 should be treated as x. So that you get 8x. And x power 1 by 3. So here the cube is only for x power 1 by 3 and not for 8 because here the cube is only for x, not for 8. So you get 8x. So this is your, so your f of g of x is equal to 8x. So you have found f of g and g of f. So you have found g of f is 2x, f of g is 8x. Fine. So all of you can pause the video and take the notes. I'll go to the next one, which is the fourth one. Let me erase this. So fourth question is, so what is given? F of x is given. F of x is given as given is f of x equal to 4x plus 3 by 6x minus 4, comma x is not equal to 2 by 3. Obviously when x becomes 2 by 3, the denominator becomes 0 and the function is not defined there. We have to show that, right? To show or to prove or should show that f of x equal to x. We have to find f of x equal to x, right? For all, obviously x is not equal to 2 by 3. And what is the inverse of f? Also, what is f inverse? We have to find what is f inverse also. What is f inverse? Question mark. So these two are the questions, first and second. No proof or solution, whatever. Now we need to prove that f of x equal to x. F of x equal to x. Let's try to find what is f of x. So f of x is, so I'll write here. So f of x equal to f of x. That is equal to f of, what is f of x? F of x is 4x plus 3 by, so this becomes f of, instead of this f I'll put 4x plus 3 by 6x minus 4, right? Because f of x is 4x plus 3 by 6x minus 4. Now what is f of, again the function, so that will be equal to 4 into, so f of x, you have to treat this whole thing as again x and substitute in this function. So what is f of x? F of x is 4x plus 3 by 6x minus 4. So we have to treat this entire thing as x and substitute that here in the place of x. I'm going to put this entire expression. So 4 into x, but x is what? X is 4x plus 3 by 6x minus 4. This is 4x. So f of x is 4x plus 3 by 6 into x. X is 4x plus 3 by 6x minus 4 minus 4. So f of x is 4x plus 3 by 6x minus 4, like this, because this is f of this entire thing. So this entire thing should be treated as x. So this is 4x plus 3, 6x minus 4. Now if you simplify this, right, so now we get this is equal to 4 into 4x plus 3, this is by 1, adding it. So this into this plus 3 into 6x minus 4 by 6x minus 4 into 1 is 6x minus 4 whole divided by this one. This is 6 into 4x plus 3 minus 4 into 6x minus 4 by 6x minus 4. Now 6x minus 4, 6x minus 4 will get cancelled. Now finally we will get that is equal to 4 into 4 is 16x plus 12 plus 18x minus 12 by, here you get 24x plus 18, this is minus 24x plus 16, right? Minus to minus is 16. So these two will get cancelled and 24 will get cancelled. You will get 34x by 18 plus 16 is again 34, which gives you x. So what we have proved? We have proved f of x equal to x. So f of x equal to x, right? So we have solved the first part. The second question is easy. So we have proved f of x is x, and again it is true for all, right? True for all x not equal to 2 by 3, obviously, because when x is 2 by 3 the functions are not defined, right? So this is true for all x is equal to 2 by 3. F of x equal to x for all x is equal to 2 by 3. Now what is f inverse? So what we have got? We have got f of x equal to x, which means this is an identity function. So if the composition of two function gives you an identity function, then one is the inverse of other. The composition of two function gives you identity function. Even if I do the reverse way, reverse is also f of f only, right? If g of f is an identity function and your f of g is also an identity function, then one is called as inverse of other, which means g is called as inverse of f or f is called as inverse of g. But here if I do the reverse, that will also be f of x, which will be same as this. So therefore what we can say, therefore f is the inverse of f. F is the inverse of f, which means the function f itself is the inverse of itself. F is the inverse of f means what? F is inverse of itself. F is the inverse of itself. Inverse of itself. Itself means for the f. For the f, the function f is the inverse, which means your f inverse equal to f. In other words, what we can say, your f inverse equal to f, which means the function and the inverse are the same function. They are one and the same function. Fine. So this completes your second part. So what is f inverse? F inverse is f. F is the inverse of itself, which means f inverse is what? F inverse is f itself. The inverse of f is f itself. Fine. So all of you can pause the video and take the notes. I'll go to the fifth question. So fifth question is state the reason whether the following functions have inverse. So first function. So fifth one, first question. F is a function from 1, 2, 3, 4 set to the set 10 and defined as f is equal to 1, 10, 2, 10, 3, 10 and 4, 10. Right? Now we have to check whether this function has an inverse. So clearly what f is what? F goes to 1 goes to 10, 2 goes to 10, 3 goes to 10, 4 goes to 10. If you want, you can draw an arrow diagram quickly and then also write 1, 2, 3, 4 and this is 10 and this is the function f. So 1 goes to 10, 2 goes to 10, 3 goes to 10, 4 goes to 10. That is the meaning of this. Now what is this function? It's not a one-to-one function. It's a many-to-one function because many are going to the same element. So we'll say clearly f is not a one-to-one function, not one-to-one. When f is not 1 to 1, then it cannot have an inverse, because a function f is said to be invertible if f is 1 to 1 and onto. If f is a 1 to 1 and onto function, then f has an inverse. If f is not 1 to 1 or not onto, then f cannot have an inverse. So clearly f is not 1 to 1, therefore clearly I have not written clearly f is not 1 to 1, therefore f is not invertible, which means f does not have an inverse. F is not invertible means f does not have an inverse. F is not invertible. Now fifth problem, second one. So what is the function f? The f is defined as g, not f, it is g. G is 5, the set is 5, 6, 7, 8 to the set 1, 2, 3, 4, and defined as g is equal to 5, 4, 6, 3, 7, 4, 8, 2. 8, 2. Fine. So this is how the definition of G is. Now we will have to see whether G has an inverse, and G will have an inverse if G is 1 to 1 and on. We just need to check whether G is 1 to 1 and on. So see, when you have very minimal elements, and when it is given like know which element is mapped to which element, then we can quickly check and find out, right? So we can even put an arrow diagram and to see whether it is 1 to 1 and on to. So 5, 6, 7, 8, 1, 2, 3, 4. And this is your G set, G function. This is this set. So G is a function. Now 5 goes to 4. So 5 goes to 4. Then 6 goes to 3. 6 goes to 3. 7 goes to 4. 7 goes to 4. 8 goes to 2. 8 goes to 2. So clearly it is not 1 to 1, because 5 and 7 are both are going to 4. Two elements are going to the same thing. So we'll say clearly G is not 1 to 1, right? Therefore, why it is not 1 to 1? Because 5 also goes to 4, 7 also goes to 4. So therefore we can say G is not invertible, which means G does not have an inverse, right? Even it is not on to also here, because 1 is there, it does not have an x, any element here such that some element is getting mapped to 1. Even it is also not on to. But even not 1 to 1 itself is enough to say that it is not a invertible function. Fine. Now next one, fifth one, third. Fifth one, third subdivision. What we have in third subdivision? H is a function. H is a function from the set 2, 3, 4, 5 to the set 7, 9, 11 and 13, and defined by H is equal to 2, 7, 3, 9, 4, 11, 5, 13. So this is how the H is defined. Now we have to check whether H has an inverse, which means we should check whether H is 1 to 1 and onto. If H is 1 to 1 and onto, then H has an inverse, right? If H is 1 to 1 and onto, then H will have an inverse. Now let's try to check whether H has an inverse. I mean H is 1 to 1 and onto, which means we have to check whether H is 1 to 1 and onto. Now if you try to see 2 goes to 7, 3 goes to 9, 4 goes to 11, 5 goes to 13, which means different elements are going to different images. Therefore it is 1 to 1. Also every element here has a pre-image. 7 is 7's image, 2 is the element, with 2 goes to 7, 9, 3 goes to 9, 11, 4 goes to 11, 13, 5 goes to 13. So therefore it is on to also. So it is both 1 to 1 and on to. Or you can even write the arrow diagram quickly to check this also. 2, 3, 4 and 5, 7, 9, 11, 13. So 2 goes to 7, 3 goes to 9, 4 goes to 11, 5 goes to 30. Fine. So this is how the definition of H is. So clearly it is what? It is 1 to 1 and on to. Right? 1 to 1 and on to. So we'll say clearly H is 1 to 1 and on to. Therefore H is invertible. H is an invertible function. So H has an inverse. H has an inverse. So H is invertible. Thanks. That is for the third question. Fine. So all of you can pause the video and take the notes. I will stop the session here. You can watch my next session for the continuity of this exercise. Please watch my next video for the next set of questions. Thank you for watching. See you all in the next video. Thank you.